behind her. Okay, anyway, here we go. So this one is sine, and we're doing graphing, and your next test is on graphing, and it's right before spring break, and it's 6 days. Well, the test is 1 week from today. Okay, I'm not kidding. So we go kind of fast in honors pre-calc. This would be probably a week and a half or 2 weeks in regular, but hey, you are in honors, so lucky you. It won't be as long, but you'll learn just as much. So here we go. 0, 2 pi. What? I know when I first saw this, I thought, what are the angles doing down there? So what's halfway between 0 and 2 pi? Pi. It's kind of like somebody took the unit circle and rolled it out. And if they took the unit circle and just kind of took this circle and kind of, I wish I could roll it. There we go. Except could I roll it and go to the right at the same time? Anyway, if I could, I would have right there. And this 0 and pi and 2 pi are all things that would be on the circle, right? What's in between those? Half of pi, also known as pi over 2. And then if you can count by pi over 2's, that first spot is 1 pi over 2. What's the second spot? No. That spot, 2 pi over 2, which reduces to pi, so I can know it's working. Okay, and then what's the next spot? 3 pi over 2. There we go. So those are the 4 important spots. Actually, I lied. There's 5. 0 is kind of, you should know that one automatically, but it's a spot. And then there's this spot and this spot, which are pretty easy to figure out. What was the highest value sine ever had? 1 is correct. 1 is the highest sine ever got to. And take a wild guess what the lowest is you ever get to? -1. So then my graph goes between 1 and -1. Did you see cycling back and forth and back and forth? If I wanted to, I could continue it forever in this direction and forever in that direction. And yeah, sine just keeps going. Okay, so there's sine. Now, what if I wanted to do a stretch? Do you remember back when we had life was simple and you just had like parabolas that were getting moved around and stuff? This would move where? Right 3. What if I put a -7? It would move it down 7. Those things still happen, except now with sine parent functions get moved around. And what if I put a 5 here? That would be a vertical or a horizontal thing? Vertical. That'd be a vertical what? Stretch, and it would be 5 times as high as it used to be. This thing, 5's a little bit much, but if I wanted to do one like that for this, I'd start with y equals sine of x, and if I put, somebody was talking and it threw my writing off, fk, sine of x, if I put a negative out in front of it, that's going to make it, what do you think? Flip it. If I put a negative right there, that would flip it. Can you picture it doing that instead? Yes. Yes. All right, so let's say that there's a 2 in front. Would you agree it's vertical because it's on the outside? Okay, and then is it a stretch or a shrink? You can trust the stuff on the outside. And so this seems like it's twice as big, and it is, because you can trust the stuff on the outside. So it's twice as tall. Here's what it would look like. It went up as twice as high, and it went down twice as low. You guys getting that? Does that make sense to you? It's just twice as high as it used to be and twice as low as it used to be. All right. Take a guess what would happen if I may put a 1/2 right in front of it. Yeah, half as high as it used to go. You might actually like these better because they kind of like, I think, they make as much or more sense than when we were graphing like parabolas and stuff. Because now this just rises to as half as high as it used to go and half as low as it used to go. And does that make sense? Okay. Now what's more complicated is if I put something on the inside. And we have to know that for today. What if I put a number there like 5? Do you remember that the stuff on the inside does the opposite of what you expect it to do? So it seems like I did 5 times the horizontal, which should stretch it way out. So instead, it shrinks it up, okay? And so when you got these, it's kind of like a spring, and it's kind of like you're compressing the spring. Now 5 is kind of an icky number, but how about if I do a 2 in there? Would you agree that a 2 would make it not twice as wide, but half as wide? And can you picture then it would go like that? It still needs to go just as high and just as low, but it got squished. It's like I grabbed this part with my hand. Let's say I put my hand around it here, and I grab it, and I push it over here, and I squish the spring down to be half as big as it used to be. Okay? All right. Now, how would we label that? Here's how this works. There's some terminology you need to know next that goes like this. Wait a second. Don't write this one down. I'm just going to give you a blast from the past. I always try to connect things like this to past experiences. Parabola. What's that, and that? Yes, there's x-intercepts in there. There's y-intercepts in there, but that's not really what I'm asking. It's 3 distinct numbers there, and they're called... Say it louder, John. A, B, and C. You are correct. Because, have you ever heard of a squared plus b squared minus 2ab cosine c, that kind of stuff? Okay, so we got a's and b's, and what do we use this for? X equals negative b plus or minus square root b squared minus 4ac over 2a. Very nice. I guess this could be a choir class. Sometimes that happens where all the choir kids are in 1 hour. I don't know. Maybe that's it. All right. So this was A, this was B, and this was C. In case you forgot, that's the old stuff. Now, what about now? Well, now we have y equals a sine of b parentheses x minus c plus d. It's got a, b, c, and d. I'll move this up. I know it's easier for people in the back to see if it's up there. Okay, so A is your vertical stretching spot, or shrinking if it's like a fraction. And that's called the amplitude. In these, we have slightly different naming than we did under the old system with like just a parabola. That's called amplitude. And what amplitude is when you see a graph that's like a sine graph and it's going like this, amplitude is how high it goes. You remember how high standard sine went? It went 1. You know why? Because we had a 1 in front of it. How high would it go if we had a 2 in front of it? 2. Get the idea? Now, common misconception here is that if we make the amplitude is like how high it is, people will go, see, it goes from there to there. No, you can't do that. It's kind of like measuring a wave on the ocean. They don't measure a wave. Well, you can. But a wave is measured from the middle up, because it's kind of like if the ocean went flat. Think about that. If the water calmed down, it would all be like right here. Okay, so anyway, the amplitude is how far up off a normal it is, or off of flat. Okay, so that's A. That's the amplitude. Okay, so that first one's called amp for amplitude. B, that B is the inside. It's inside, and I could even, these are optional, put parentheses around that just to show you that that's all the inside stuff. Okay, and on the inside, that's all the horizontal. I'm going to put high above it. What do you think it stands for? Horizontal on the inside. All right, and then this is a bow vertically on the outside. All right, so how about then if I give you, I'm teaching you like a lot of stuff here. I know that, going really fast. I know that. It's because this is a super short unit. This, honestly, we aren't cutting this unit down from normal to try to make it work by spring break. It has always been this long, and it's always been really quick. It just happens to work perfectly. We can get this done in the 6 days of including the test. So, all right. So anyway, 5 days, actually 4 days of new material, 1 day of review, and then the test 1 week from today. All right. So here's the next formula I need you to know. Please write this down. That the period is equal to 2 pi over b. Right now, you may not understand what that means yet. Do you remember that 2 pi was how long our graph was? It started and ended, and it finished at 2 pi. So, see, I'll go back to, hold on just a second here. Oh, okay. All right. Thank you. I get what you're saying. In here, from 0 to 2 pi, that distance right there, that is called 1 period because the graph starts and ends, and it's like ready to start its next cycle. And it's going to go up and then down, and then it's going to come back to 0. And anyway, it keeps going and going. And that is called its period. And its period will change if I mess with b. So I'm going to scroll back down again. What if b was like a 3 in here? Well, then it would be 2 pi over 3 is how long it takes for the graph to finish one cycle. 3s are not nice. I'm going to go with 2. Let's say I put a 2 in there. And here's how the graph would look. You'd have sine of 2x. Would you agree that that's going to be different shaped than just plain sine? Now think about it. Did I mess with the horizontal or the vertical? Horizontal. And so then if I were to look at a normal sine graph and it looks like this, horizontally it's going to squish or stretch. Remember, it seems like stretch. Instead, it's going to be shrink, okay, or squish. And that means it's going to finish its cycle in half the amount of time. Notice where it ended was 2 pi. That's for normal sine. This one's period will make it end at 2 pi over 2. You just divide by whatever number that is. So then, if the old numbers were 2 pi, pi over 2, and this one's the hardest one, 3 pi over 2, my new numbers, you divide everything by 2. Watch what happens. The period used to be 2 pi, and now it's 2 pi divided by 2. If I multiply that one by 1/2, I have to multiply everything by 1/2. And now my new numbers are pi over 4, pi over 2, 3 pi over 4, and 2 pi over 2, which is also known as pi. It wraps up a complete cycle now faster. It gets it done at just pi. But notice I didn't have to redraw the graph. That's what we're going to do for you also. So here's standard sine. And a kid has to make a change to it. You always just start with regular sine. 2 pi, pi, pi over 2, 3 pi over 2. You're going to be good at that after a while. You'll be able to draw that in your sleep. And then I say, oh, wait, it's going to be sine of 4x. You'll have to know, oh, divide all, including the period. Divide everything by what? 4. Divide by 4. And I like to instead times by 1/4. Times 1/4 times 1/4. My new numbers are pi over 8, pi over 4, 3 pi over 8, 2 pi over 4, which can be reduced to pi over 2. There. That's one of the hardest things. It's actually super easy to move the graph. Let's say I just wanted to take normal sine, because again, you always start with that. And then, let's say I wanted to go like this. I want to move it this way. Which way did I just move it? Right or left? Right. It's counterintuitive because it's on the inside. Okay. Right, how far? Pi over 2. So I would grab this and move it. Oh, wait, it's going to move the numbers too. Okay, I'm going to draw over it. I'm going to grab that and move it how far? There, I moved it pi over 2. It got shifted to the right. Those are super easy to do. On your iPad, when you're doing these, you're going to draw them. Try to use just one line. Okay, so then you can grab it with the little lasso tool, drag it to the right, drag it to the left. Makes it nice and easy. Okay, so that's sine except shifted right. How would I have shifted it left if I made it, yeah, plus? What if I wanted to flip it over? Put a minus here, and it would have flipped to be like that. What if it was flipped and moved? Positive means to the left, so I'd go like this. And how far is pi over 2? It's that far. One notch. See? All right. So that's the basics. Now you just need two more things. I told you what sine was. Now let me show you what cosine is. Okay. How fast can Mr. Server draw sine? You ready? Get your timer ready. On your mark. Get set. Go. Done. Dang it, the 0. Come on, you're going to hit me for the 0? It's 9 seconds. All right, so that doesn't take... Okay, fine. I'm going to round it to 10 seconds then. It took me 10 seconds. You'll get good at it too. In fact, frankly, you're younger and you're supposed to have better physical dexterity than me. I'm already old and I've lost my, not my marbles, but I have kind of lost hand-eye coordination just a little bit. Okay, so anyway, you could draw it even faster than that if you really wanted to. So now what? What are we drawing now? Cosine. Didn't I say that they all came down to sine? Here's what cosine is. It's just shifted. I know you're thinking that doesn't look as pretty. Well, when I draw just cosine on the graph, it'll make sense to you. Okay, here's just cosine. Not going for hyperspeed this time, but I'm going to start at 1. And I like to do this in 4 parts. Part 1, part 2, part 3, part 4. And it's like a big valley. Like these are the mountains, and then this is a valley. All right, so anyway, it has still got the same thing. 2 pi here, pi in the middle, pi over 2 right here, and what do you think that spot is? 3 pi over 2. Think of it counting as 1 pi over 2, 2 pi over 2, 3 pi over 2, and this would be like 4 pi over 2, which would reduce to 2 pi. Okay, there we go. And then how high do you think this is? How low do you think that is? -1. There's cosine. Now some of you are like, that's not what you drew before. It was. I just had it like this. I had only this part of it drawn before. But do you get it's a wave that keeps going forever? And we just kind of focus on that first part. Why? Because it's the part that's between 0 and 2 pi. Just like on the circle, between 0 and all the way around until we get to 2 pi. 1 full time around the circle. All right, so there's cosine. I encourage you to get to know these well because that's what you start with on every graphing problem. Is you start with the parent one, and then you just shift it and move it and flip it and do stuff to it. Okay? There's sine and cosine, and even tangent still just boils down to sine. But do you remember what tangent technically was? Sine, off the identity sheet, sine over cosine. So if I took sine and put it on the same graph as cosine, if you can see where one is divided by the other, you're a better person than I am. This is really hard to do. To divide the sine graph, which is the blue one, by the cosine. But how about this? Would you agree with this? Where are you going to have a problem? Whenever cosine of x is what? 0, because you can't divide by 0, right? So wherever cosine hits 0, which one's cosine? The red one or the blue one? The red one. Wherever the red one hits 0, which is right here, and right here, those are the two spots where cosine hits 0. We have asymptotes right there. So that means tangent has asymptotes. All right, so now the big reveal. Here's tangent. I like the dotted line drawer for the asymptotes here. And those asymptotes are at, if anybody has a short-term memory, pi over 2, and then the other one was like 3 pi over 2, but we would like to call it negative pi over 2 because it'll give us more symmetry. To get how we go this way, half of a pi, and that way, half of a pi should be negative. And then here's another way to say that. Would you agree that this spot here is called 3 pi over 2, but it's also called negative pi over 2? Huh? Okay. 12-minute warning. So we should be getting in the homework soon, and we will. The last one I got to give you then is the actual graph of tangent. I've got it all set up. So far, I just have the places that it isn't. Here's the places where it is. And as you can imagine, we have more than one significant point, but thankfully, only 2 more. One's exactly halfway here, which would be pi over 4. Hint, half of pi over 2. Think if you times this by half, it'd be pi over 4. Okay, then this other spot, negative pi over 4. And at those spots, I betcha you won't be too surprised to find out that it's 1 and negative 1. Does that make sense to you? The other one before hit 1 and negative 1. Remember, sine, highest it ever went was 1. Lowest it ever went was negative 1. It happens to work out that those are the significant spots here for tangent. All right, so this looks completely different, obviously. It's not a wave, but it is a cycle. And this one's period is not 2 pi. Think about it. How far is that? Pi over 2. How far is that? Pi over 2. How far is the total then? Pi. So the period of tangent is pi. It gets one full cycle over with in pi. All right, now we got to look at the homework. Everybody find, if you haven't already, find the file that's posted under today's date, March 15th. I'm going to pause for a second. We'll pull that. So here's our assignment. It's day 1. And it says cosine of x minus pi over 2. Now, I've already filled this out from the other hour, and I'm not going to erase it and then refill it in for you. But I'm going to talk you through it at least. First thought, I've sketched it up here. Do you get I sketched it in the normal place and then I moved it to the right? Why would I have moved that black graph to the right? Because of the minus pi over 2. That tells me graph it and then move it to the right, pi over 2. How far do you think this is that I moved it? Pi over 2. All right, so I'm kind of jumping to the end here, but this graph would have been right there originally, right? That's how sine looks originally. And then you grab it and you drag it over. Now, let me drag it over. You'll have to imagine where it was a second ago. You drag it to the right. 1 mark, also known as pi over 2. How long is the period of normal cosine? 2 pi. Was there a b term? No, there was no number there. So then the b is just 1. So that means if I'm going to continue my formula, period is 2 pi over b, but b is 1. So the period is just 2 pi. And then right pi over 2 is how I shifted it horizontally. There was no vertical shift because there was no number out here. Its a was the number in front, which is 1. Its b, we just established a second ago, there's no number there, so it's 1. Its c is, that's called c, and it's negative pi over 2. And last but not least, d was this last number, and there was no number there, so I put a 0. Okay, now for the graphs, I don't like these. I think they're hideous. I wouldn't use them. I'd just draw it like this. And then you can label those spots so easily. 2 pi, pi over 2, And the middle one was the hardest, 3 pi over 2. And that's like if you were going around the unit circle, you'd start with 0, then you go to pi over 2, then you'd go to pi, and then you'd go to 3 pi over 2, and then you'd go all the way back to here and call it 2 pi. That's where those 4 numbers came from, in case you hadn't made that connection yet. Okay, there, you're done with the first day of graphing. I have noticed there are people who are going to split up on this one. Our last test was fantastic. I can't believe you did that well. That was amazing. But this test, we're going to have a split where some people are good at graphing and some people aren't. And then there's 2 subsets there, too. Some people are good at graphing and they'll just get A's. And the other people that are bad at graphing, some people will work at it really hard and they'll still get A's. But other people are naturally not good at graphing and they're sleeping right now, so I'm not going to want to wake them up. And they're going to not study this, so then they won't do that well. You get what I'm saying? I'm just saying, if you're not good at graphing, don't go, oh, I guess I'm toast. You can actually study your way to doing okay. All right, and that's all I have for you. Oh, wait, these 3 problems plus the next page, 3 more problems on the next page. Okay, so that'll be 6 questions total. I think that's doable.